You are almost at the International Space Station. The ISS is a crowning achievement of international cooperation, and you are here as a new astronaut and systems engineer to first learn about the ISS, then work on improving its various operations. But first, let's make sure the docking process goes smoothly, so that you can arrive safely at the station. Now that you are ready, let's have a look at SD1. The ISS has many functions that are independent of each other, so the main process of the system is asynchronous. As you can see, this OPD is not complete, as only two sub-processes carry out transformations, docking and undocking. For our purpose now, this is okay, because these are the processes we will focus on. Both docking and undocking require a docking port, which is part of the ISS. These two processes also require shuttle, which is an environmental object arriving from Earth. That's where you are right now. Finally, both these processes transform the attribute physical relation to shuttle of docking port by affecting it, switching between its states. If we wish to show how docking is done in more detail, adding new objects and processes in SD1 would not be a good idea, as it is already filled with OPM things and links connecting them. To avoid rendering the OPD too crowded, we apply refining again to create a new OPD for docking, SD 1.1. Let's have Hopcat explain this to us.
OPD Detail Hierarchy Principle. OPDs are arranged hierarchically in a tree structure, such that SD is the root.
Thanks, Hopcat. Refining a process in SD1 is done in the same way as in SD. Here too, we need to think whether the process being refined is synchronous or asynchronous. However, refining SD1 can result in more than one descendant OPD. This is because SD1 normally includes multiple systemic processes, while SD normally includes only one systemic process, which is part of the system's function. Since docking is synchronous, we zoom into docking. Let's name these three processes contacting, attaching, and securing, and position them in the order from top down within docking in zoomed ellipse. The new OPL sentence reads, docking from SD1 zooms in SD 1.1 into contacting, attaching, and securing, which occur in that time sequence. Physical relation to shuttle is an attribute of docking port with two expressed states, disconnected and secured. Let us also express two additional states, which until now have been suppressed. Connected and attached. Having expressed all the four states of docking port's physical relation to shuttle, we now model how each of the three sub-processes changes the state of physical relation to shuttle. Only one astronaut is required for the docking process. Approaching is an environmental process that the shuttle performs. Let us add it. Speed relative to docking port is an attribute of shuttle that we wish to model, as its values are related to the three sub-processes we just modeled. Since speed relative to docking port is an attribute of shuttle, which is an environmental object, this attribute is also environmental. Speed is a continuous attribute measured in units of FPS, short for feet per second. Let us add this into the object. We are interested in specific speed values or value ranges, which we will model. The initial value is any speed greater than 0.1 FPS. So we write the range v is larger than 0.1 as the first value of the shuttle's attribute speed relative to docking port. The next value is v equals 0.1. Then the range v is greater than 0 and smaller than 0.1. And finally, v equals 0. Now we connect the first two values to approaching with an input-output link pair. This generates the OPL sentence approaching changes speed relative to docking port of shuttle in FPS from v greater than 0.1 to v equals 0.1. At this point, docking starts with its first subprocess contacting, such that contacting changes the speed from 0.1 FPS to almost 0. Next, attaching occurs, causing the relative speed to become 0. When there is no relative movement between the ISS and the shuttle, the astronaut can perform the securing process. And we are done with SD 1.1. To complete the model at the second level of detail, we need to refine undocking in a new OPD, SD 1.2, and do the same for the rest of the processes modeled at the first level of detail. Our time is up, so we will not do this here. The terms we use become more domain-specific and technical as we drill deeper. We can navigate through the different OPDs in our model in this way. You are now aboard the ISS. Enjoy your time at the ISS and see you soon!